So to answer part A of this question, you first want to develop a simple procedure we can convert to computer code on how to determine the area of this pyramid. So the way that we're going to do that is we're going to take the area of a given layer and we're going to subtract the top area of that layer from the layer below it. So this layer right here above, which we'll call layer 4, we want to subtract that area from this area right here. So what does that look like? In this example, we have 5 layers with each cube having a length of 1. So the area of this bottom layer right here is 4 because it has 4 sides times 5 because each of these cubes has a unit area of just 1 and there's 5 of them. So then we have to add to that the top view of that, which is simply 5 times 5 because we have 5 cubes this way and 5 cubes this way, each with a unit area of 1. And that gives us the area of just this layer right here. From that, we need to subtract the red area, which is simply 4 times 4 because we have 4 cubes going this way like so and 4 cubes going this way, which gives us an area of 16. So that is just an example of how that would work. In our code, we have exactly that, except we do it for every single layer. So here in line 2, we define a variable called area thus far, which keeps track of the amount of area we have accumulated thus far. We have a for loop that's going to go from 5 to 4 to 3 to 2 to 1. I did it this way simply because that's the way that our procedure is visualizing it. We're going from the bottom to the top, but you could have done it in reverse. You could have done it from 1 to 5, or rather from the top to the bottom, and it would have worked the exact same way with some slight modifications. So how does it work? It works pretty much exactly how we explained it. This formula, which is 4 times the number of layers plus layer squared, L squared, minus L minus 1 squared. This is just in abstract terms the exact same process that we followed here. And that's for each layer. And at the very end, once we have that area of the entire pyramid, we need to scale that by the length of the cube squared. And this is because the area of, or rather, yes, the area will scale quadratically in accordance with the change in the length of each individual cube. So for example, if each of these cubes were instead now 4 units in area, you can see why. We changed the length to 2, but the area of each cube increased by 2 times 2, which is equal to 4. So at the very end, we want to scale the entire thing by the length of the cube squared, which is what we do in line 7. Now to answer part B is a slightly more complicated question. It involves some math, which I may have to answer in a separate video.